Hi everybody, welcome back to section 5.2. In this video, we're going to be covering example 2, letters A through I using substitution. So let's go and look at example A. These are pretty close together. So what I did is space them out on the separate document here. So example 2, same questions. Let's look at example A. So we have the integral of 4e to the 5x minus 8 dx. Once again, we don't know how to solve this integral, and we're going to need to use substitution. So here what we're going to do is let u equal 5x minus 8, and we're going to take the derivative of u. So this would be 5 dx. We're going to move 5 over to the left side. So what we'll end up with is dx equals du over 5. And so I'm going to plug in this u and this du over 5 into our integral. So this is going to equal 4e to the u du over 5. The u equals 5x minus 8. This goes into our exponent, and dx equals du over 5. So now we have our new integral here in terms of u. So let me go ahead and simplify this a bit more. I can combine this 4 and 5 to be the integral of 4/5 e to the u du. And this is a pretty simple integral. The integral of e to the u is just going to be itself. So what we'll have here is 4/5 e to the u plus c. And then our last step is to plug in what u equals. So I'm going to plug back in 5x minus 8 because we want everything in terms of x. So 4/5 e to the 5x minus 8 plus c. Okay, and that is our answer for A. And for reference, this is an example of if your u is in the exponent. So if we go back to our suggestions, if it's an exponential expression, you let u be in the exponent. Okay, let's go ahead and look at example B now. So we have 10x minus 7 times 5x squared minus 7x to the fourth. Okay, so this is an example of a power where we have choose u to be a power or radical. So it's the base of the radicand. So what we'll do here is choose u to be this base of the power 5x squared minus 7x. So let's go ahead and take care of this. So we have let u equal 5x squared minus 7x. That means du equals 10x minus 7. Remember, we're taking the derivative. And attached on is going to be this dx. So put parentheses here, but I'm going to divide both sides by 10x minus 7. And so what I'll end up with is dx equals du over 10x minus 7. So once again, I'm going to take this u and this du over 10x minus 7 and plug them into our integral to get a new one. So let me clean this up a bit, but what we end up with is the integral of 10x minus 7 times u to the fourth times du over 10x minus 7. And so this works out really well because this 10x minus 7's cancel out. And what I'm left with is the integral of u to the fourth du. And so the integral of this u to the fourth du is fairly easy. So it's going to be u to the fifth over 5 plus c. And then last step is to plug back in what our u equals to get it in terms of x. So what we end up with is 5x squared minus 7x to the fifth over 5 plus c. And that is our final answer. Okay, now let's go ahead and check out letter C, where we have the integral of x to the times x squared minus 5 to the 1/3 power. So this is the same situation as a previous problem where we have a power, but what we need to do is let u equal the base of this power. So what we're going to have is u be x squared minus 5. And we're going to take the derivative of x squared minus 5 to be 2x dx. And again, we're going to move everything over to have dx by itself. So I'm going to divide by 2x to both sides. I'll have du over 2x. Okay, so I have my u and I have my dx. So what I need to do now is substitute both of these into our integral. So I'll have the integral of x u to the 1/3, and my dx equals du over 2x. Okay, so our x's cancel out, and what I'm left with is the integral of u to the 1/3 over 2 du. Okay, so let me clean this up a bit. So I want to move this 1/2 out in front of the 1/3, so the integral looks a little easier to take. So the antiderivative of u to the 1/3 is going to be 1/2 times u to the 1/3 plus 1 over 1/3 plus 1. And 1/3 plus 1 is going to be 4/3. So this is 1/2 u to the 4/3 over 4/3. And so with that 4/3, you flip up to be 1/2 times 3/4 u to the 4/3. And so it becomes 3 over 8 u to the 4/3. And then the last step is to plug in what u equals, which is x squared minus 5. So we end up with 3/8 x squared minus 5 to the 4/3. Okay, let's move on to the next problem, letter D. And this is an example where we let our u be the denominator. Okay, so we will let u equal 3x squared plus 2x plus 5. We take the derivative of u, so that would be 6x plus 2 dx. And we want to get dx by itself, so I'm going to divide 6x plus 2 to both sides. So du over 6x plus 2. So same process, I'm just going to substitute in u and du into my integral. So this equals the integral of 24x plus 8 over u times du over 6x plus 2. So if you see, this does not cancel out immediately as in previous problems, but what we can do is factor out a 4 out of 24x plus 8 to have the same 6x plus 2. So let's do that. So I could factor out a 4 and have 6x plus 2 over u times du over 6x plus 2. And so these 6x plus 2's cancel out. And so what I'm left with is the integral of 4 over u du. And to make this a little easier to see the antiderivative or the integral, I'm going to move this 4 out in front and have 1 over u du. And the integral of 1 over u is just going to be natural log of u. So this will be 4 natural log of u plus c. And I can just substitute in what u equals, which is 3x squared plus 2x plus 5. And my final answer would be 4 natural log of 3x squared plus 2x plus 5 plus c. And that is my final answer. Okay, last problem, letter E, we have 4x minus e to negative 2x dx. So to make this a little easier to see, what I can do is split up this integral. So what I can have is the integral of 4x dx minus the integral of e to the negative 2x dx. It's an integral property we can use, and it makes our substitution easier to see. So this left integral is pretty straightforward. We don't have to do any substitution with this, but we need substitution with this right side integral. What I need to do for this right side, let me first close off previous work, but I need to let u equal negative 2x. And then I need to take the derivative of that negative 2x. So that would just be negative 2 dx. And I'll move over that negative 2. So it'll be du over negative 2. So this would end up being rewriting the integral of 4x dx minus the integral of e to the u times du over negative 2. Okay, so let me clean this up a little bit more. What I'm going to do is move outside this negative 2. I can move that outside of the integral because it's just a coefficient, and I can move coefficients in and out of integrals as stated in our integration properties. So this will be the integral of 4x dx plus 1/2 e to the u du. Negative and a negative make a positive, so it becomes positive 1/2. But let's go ahead and integrate this now. So the integral of 4x dx is just going to be 4x squared over 2 plus 1/2. The 1/2 does not change. And the integral of e to the u is just going to be e to the u. And then I have a plus c on the end. Okay, so last step to do is plug back in what our u equals, and u equals negative 2x. So our final answer would be 2x squared plus 1/2 e to the negative 2x plus c. And that is our final answer. Okay, so that's substitution using indefinite integrals. And now the next portion would be using definite integrals, but we'll save that for next time. And I'll see you. Thank you. Bye.